So we're going to go over the vital parts of the immune system, and I'm going to try to incorporate as much of the lymphatic system and how it relates to it as possible. So you wake up one morning with a stuffy nose, slight fever, and fatigue. Do you have a cold or the flu, or are they the same? Should you go to the doctor for an antibiotic? Why or why not? So for this, looking at the symptoms, do you think it's a cold or the flu? And then thinking about antibiotic use, could you use this for a cold or the flu? So I'm going to go over the difference between a cold and the flu in a second. All right, so you can see the differences between a cold and the flu. So some of the major things that you'll see associated with a cold will be fatigue, some aches, pains, headache, sore throat is very common, sneezing, stuffy nose. But as with the flu, it's going to be more fatigue, aches, pains, some chest discomfort, maybe headache, fever, etc. So you can see the differences between the cold and the flu. But thinking back to the question, do you think that was a cold or the flu? All right, so looking back, stuffy nose, slight fever, fatigue. So is that cold, flu? Stuffy nose, slight fever, fatigue. So going back, stuffy nose, so typically with a cold, fever, typically with a flu, fatigue could be with both. So technically this could be a cold or a flu. I would say it's more related to a cold, but since it has that slight fever, it makes you think that it's more likely a flu. So it's really hard sometimes to tell the difference between a cold and the flu, and the only true way is to look at what a cold is versus what the flu is, which we're going to go over in a second. All right, so starting with a cold. So a cold is caused by what's called a rhinovirus. So what it's going to do is cause an infection of the mucous membranes. So that's why you have so much sneezing, runny nose, etc. All of those components associated with the mucous membranes. There are over 100 different types of rhinoviruses. So if you remember, I talked a little bit about immunity and how once you have something, you typically cannot get it again. The problem is with colds, there's over 100 different types of rhinoviruses. And I know for me, I usually get about 2 colds a year. So if you think about in my lifetime, if I consistently had 2 colds every year, I wouldn't be immune to every single rhinovirus until I was over 50. So basically, we don't become immune to colds because each cold is a different virus. So colds and flus are both controlled by viruses. So viruses, if you remember, cannot be killed with antibiotics. So that question, should you have an antibiotic? No, because antibiotics cannot be used for colds or flu. So the difference between viruses and bacteria. So viruses are non-living because they need our cells in order to survive, whereas bacteria are living organisms, so they can be killed with antibiotics, which break down their cell walls. So if you had a bacterial infection, you could use the antibiotic, but cold or flu, virus, you cannot use antibiotics. All right, so now we're going to look at our defenses. So you see viruses and bacteria are everywhere, where you can't really see them, but I mean, when we did our bacteria growth, you could see the growth. So what have we learned about defending ourselves from invaders in the body so far? So think back to the different systems we've talked about. So starting all the way from the beginning, if you think integumentary, we talked about sweat and oil and how that kills bacteria. We talked about more recently respiratory system, the nose, how there's cilia, mucus. We talked about just recently, the digestive system, how if an invader does get in the body, it sends a signal to the brain to have reverse peristalsis occur, and then the contractions of the stomach to release those items from the stomach before they get absorbed by the intestines. So there's different lines of defense to make sure that things do not get in the body, and if they do get in the body, how to get them out or destroy them. So first we're going to look at non-specific barriers. So things that are going to keep things out of the body. So the first one, integumentary system, so the skin is very important. So our skin is constantly shedding. So if you remember, we talked about the dead skin cells and how they like flake off. So we consistently are creating new skin layers over time. So it's hard for bacteria to colonize when it's constantly flaking off. The other thing is the sweat and the oil, which is basically like an antibiotic. It's going to kill the bacteria. And then we also talked about the respiratory system, the mucus and the cilia, which is going to capture invaders. And then when you get that tickle of the hair in your nose, you're going to sneeze and release those invaders so that they cannot get into the body. So our non-specific external barriers are going to be the things that keep things out of the body. So it's our first line of defense. So next we have innate immune response. So this is going to be if the external barriers did not work and something or an invader got into the body, and now the immune system needs to fight it. So the first thing is called a macrophage. So this is a type of white blood cell. So a macrophage, a type is called a phagocyte. So this is a white blood cell that is going to ingest invaders. Then a second thing is going to be inflammation. So this is going to increase the blood flow to that area so that we have more white blood cell response. And the last thing is fever in order to kill the bacteria or virus that has gotten into the body. So relating this back to the lymphatic system for the inflammation, the white blood cells that we need there, this is coming from the lymph and the lymph nodes signaling, hey, we need these white blood cells. So we're going to look at each one individually, starting with macrophages. So as I said, these are a type of white blood cell that are going to destroy invaders. So how do they do this? They actually ingest their invaders. So they basically wrap around, so you can see in the bottom picture, they wrap around the bacteria. They're going to form basically like a cell wall around them, and then they're going to inject with digestive enzymes to break this down into proteins. So it's really interesting how they can actually just destroy it by basically dissolving it into its components.